Hey, Evan Reese here. You know the input fields on all the features in Onshape? You know the one where you like type your length in for your extrude? Well, any input field like that is actually a window into FeatureScript itself. FeatureScript is the language that all the native features and any custom features you've used are written in. And so that implies that there is a huge amount of untapped power and potential for most users. And in this series, I'm going to walk through all of the different examples in increasing levels of complexity and technicalness of all the powerful things that you can do inside of a field in Onshape. But in this video, we're going to cover some math related things, and we're going to cover the topic of units. Onshape handles units in a unique way that may not be intuitive to you yet, but hopefully will be by the end of this video. I have seen it be one of the main areas that people get tripped up when they're starting to do more complicated expressions inside of these fields. So let's get to it. All right, let's start with an extremely basic example. We're inside the extrude feature here, and this depth field is one of the fields that I'm talking about here. So I can put any length that I want in here. I can put a 5, I can put a 10, and it's going to go ahead and put units on it for me, my workspace units, millimeters. But what if I wanted to use inches? I can just type 10 in, and that'll give me 10 inches or 1 meter or 45 centimeters. You can use whatever units you want, and it will convert them to your workspace units. This field in particular is looking for a length. So any of those units I used are a length. If I do 3 degrees, it's going to fail because it's going to say we cannot use an angle as a length. Same thing happens down here in the draft tool. This one's looking for an angle, and so it won't accept anything else. I can't put a number in there. If I just put a number, 5, it'll go ahead and add degrees for me. So that's important to know, is that certain fields are looking for a certain type of input. In fact, if you look more closely, if I type 3i, I get inch as a possible completed thing here. I get meters and millimeters if I type an m. It gives me some options of how I might want to autocomplete this. If I type d, I don't get degrees at all. So if I get rid of that, just leave it. And likewise here, if I type 3i, I don't get the inches. I only can use this isInteger function. So that's interesting to note. It kind of filters your autocomplete for you. Okay, so other stuff we can do inside of here, in addition to just typing a number, I can do some math. I can say 15 plus 14, and it will evaluate to 29. You can do subtraction as well, just as easily. Sure, why not? We can do multiplication using the asterisk, and we can do division using a slash. We can even exponentiate things. So if I have 3 to the power of 2 using the caret symbol, then it's going to be 9. So that's the square of 3. And then we can undo that by using the square root function, sqrt of 9, and that'll give us 3. But you notice that every single time I'm doing this, it's actually putting whatever I wrote inside of its own set of parentheses for me, and then having millimeters out here on the side. So I do 5 plus 4. It goes ahead and actually changes what I typed to be 5 plus 4 inside of parentheses and then millimeters. And that's where we need to start to talk about value with units. Units in Onshape are handled in a kind of unique way, and in FeatureScript parlance, it's called value with units. That's the name of a thing. So a length is value with units. An angle is value with units. A quantity is not. It's just a number. So in this case, let's get rid of everything and just talk about some of these units. If I type mm by itself, millimeter, it's actually equal to 1 millimeter. If I type inch by itself, it's equal to 1 inch, 25.4 millimeters. So each of these is a constant behind the scenes in FeatureScript that is equal to 1 of that unit. And in order to get more than 1 inch, I really am doing, if I want 3 inches, it's 3 times inch. So if I type this here, it'll automatically just write it like this because that's more readable. That's kind of how people think about it. But if you understand that it's actually multiplying them together, it's 3 times inch. That is equivalent. And if I had it this way, on the back end, inside the FeatureScript is interpreting this as 3 times inch. And that has some important implications. So if I have, let's say, 3 inches, let me open up a different field for this. I'm going to go into the variable feature, and set the mode to any, this will not complain at me if I put in, like if it's a length and I put it into an angle, put an angle into it, it will complain. But here, any, it'll take anything that evaluates to anything that is valid. So I'm just going to call this anything that I want so that I can type stuff here and it won't turn red. So if I have 3 inches and I also multiply that by 3 inches, what do we get? We actually get an area. And just for easier math, I'm going to say 1 millimeter times 1 millimeter. And that makes sense. We get 1 square millimeter. And if I do it again times 1 millimeter, you can see that we're actually getting 1 cubic millimeter. And that makes intuitive sense. Area is calculated by multiplying the length, versus the width of a rectangle. So to get an area, it makes sense that if you multiply these two things together, you're getting an area. But what if what I really meant, let's see, I'm going to change this from ones to being something more like this. So there we go. Now I'm getting a volume that's 30 millimeters. But what if what I really meant was I want 3 times 2 times 5 of just millimeters for a length? So if I come in here, or we can even do addition here. If I get rid of these, you can see that we do get just a length because 3 times 2 times 5 times millimeter is 30 millimeters. But this gets a little bit trickier if I'm doing addition. So you can see that this is going to fail. And this is because it'll tell you right here, I'm mousing over it. It says you cannot add unitless number and length. 3 and 2 are both unitless. They are not value with units. Whereas 5 is multiplied by millimeters and is treated as a value that does have units. So in order to get this to work, we have a couple of solutions. One is to add the millimeters back into each item, and that will solve. Or we can get rid of them and put all of our numbers in parentheses so that it solves independently. It gives us 3 plus 2 plus 5 times millimeter, which also works. So that's what's happening in the background when you say 5 plus 6 and just hit, if I just do that here, it'll just give me the number. But if I'm in a length parameter and I go 5 plus 6, you can see what happens. It automatically fixes the syntax for us because it knows we're looking for a length for sure. If you're not really aware, you don't really pay attention to what is happening, you may not really understand why you're running into problems later. Another interesting feature of this here is you can divide units out. If I have, let's say, I'm going to put it inside of parentheses, I'm going to have 2 millimeters squared. So that's going to go ahead and evaluate, look, 2 square millimeters. And I can divide that by millimeters and it'll bring it back down to a length value. So if I wanted to put this inside of my extrude feature for some reason, I can do that and it works because in the end, it results in a length value. I could even do this times, to the power of 4 and then divide by millimeters and divide by millimeters, and it'll still work. That's a really dumb roundabout way to do it, but you can see how you need to think of all of the units as being multiplied or divided in order to get what you're after. So that is value with units. And it's the same with degrees. You can use radians, those work together as well. One interesting note about dividing units is maybe you have, I'm going to set this, there we go, any length, whatever. And then I'm going to create a new variable and I'm going to reference that one. If I set this equal to length, I'm going to get 11, but I can also, it's 11 millimeters. I can also divide by millimeters and get just the number 11. But if I wanted to know what number that is in inches, I can divide by inches. So now this is the equivalent. 0.433 inches is 11 millimeters. And this is useful if you are using, especially things like this to concatenate strings. Like if you wanted to name a part the length that it is in a certain unit, this is how you would, this is a part of how you would accomplish that. So that's value with units. Hopefully that makes sense. If you have questions, let me know in the comments. But I wanted to talk about some more math that you can get accomplished in those fields. So here's an example. I have a diameter variable driving this sketch, and it's driving the diameter of that circle, the inscribed circle. And if I wanted to know the circumference of that circle, I don't have to measure it. I can actually just use a constant. So that'll be my variable name, and I can just do diameter times pi. So pi is a constant that we have available to us in Onshape. So if I were to get rid of the diameter part, you can see that that is going to equate to 3.142. And I think that probably is just rounded. It has more digits than that, I expect. So diameter times pi gives us the circumference. It's a nice, easy way to go. There's also a lot of trigonometric functions available, like sine. I'm just going to put a letter there so it doesn't whine at me. So we have a sine function, and if we do the sine of, let's say, 30, for example, that's going to give us 0.5. If we do 0, it should be 0. And if we do 90, it ought to be 1. So there we go. That's the sine function. Cosine works exactly the same way as you would expect, but it's out of phase with the sine function, if that makes any sense. So it's kind of like sine, but backward. What does 60 give us? So it's kind of backward from sine. There's tangent functions, and then there's also the inverses of all of these. So if I have a sine 0.5, it'll give us back 30 degrees. So you can work them both directions. There's also logarithmic functions like this, where you can, if you're doing logarithmic kind of math, you can do that. And the exp function can kind of be like the reverse of that. You can use the sine functions to generate, to manipulate numbers in some really cool ways so that you can accomplish things like this. In this example, I have an angle variable, and I've created some other variables to make sure that it comes up above the origin. And I'm using this count then. Let me show you exactly what I'm doing here. So I've got a count variable. That's how many of these pipes I have. And inside of my angle variable, you can see I've declared angle up here, and then I'm declaring the same variable down here with the variable inside of itself. So this pattern feature is going to loop through these features, and it's going to repeat their code over and over again. So every time it loops, the angle variable that I'm using to determine the height also increments up a little bit. And the reason I've got 180 degrees divided by the count is because that is giving me how much of an angle, which is 1.8, I need to sweep through to get to 180 degrees in 100 steps. So what we're getting here is my height is using the cosine function. I'll drag this out so you can see the whole equation. Cosine of the angle, and that angle is going to change every time we loop. And then I've got an amplitude here where, otherwise this would just end up going up to 1 millimeter. So I'm using this to just scale the whole thing up and down. And then because it's going to give us positive and negative numbers, I'm shifting the whole thing up by, some set amount so that it stays up here. So yeah, that's how you can use a sine function to create something like this. I also have another example where I used a similar technique. As I pattern these bumps down on this glass so that they fade out more easily. It's not a linear path. It's actually a sine wave, so that as it nears the glass and becomes almost flush, they really like coast down and you get a more subtle transition. So there's some ways that you might use sine functions. And of course you can use them for their real purpose, which is doing trigonometric math. But you don't have to. There's some creative uses that you can apply. All right, that's it for this video. I hope that you understand value with units by now. And if you do, and you didn't before, please like and subscribe. All right, we're gonna get into a lot more depth of what you can do inside of these fields. So stick with me in the next video. See you there.